Hi students, in the previous class we discussed about time invariant systems. Time invariant systems. There we did have some problems and I given a problem for your exercise also. Okay. Now in today's class we are moving on to time variant systems. Time variant system. So which system is called as a time variant? You all know what is a time invariant. Now I am explaining about time variant. So which system is called as time variant system? See, time variant system. Okay. A system is said to be time variant. A system is said to be time variant if its input and output characteristics vary with time. If its input and output characteristics vary, that is change with time. Those systems are called as time variant systems. A system is said to be a time variant system if its input and output characteristics should vary with the time. That is, the input and output characteristics of the system must and should change with the time. Then those system is called as an time variant system. Simple example. So simple, if you go for the simple example, if there is a delay, if there is a delay in the input, if there is a delay in the input, that is, there is a change in input characteristics and the output will also be delayed. Okay, if the signal is delayed at the input and it is given to a system it produces some output, it will produce some output. If that output is not equal to the delayed output, then we can say those systems are as time variant systems. Or simply, if you want to show them as graphically, see, this is the input signal, for that this is the output, okay. Now input is delayed by some time, and if I apply that to the same system, then output, so there is a delay in the output. If this delay is not equal to this delay, that is, if the waveform is not like this, other than this one, that is, if the waveform does not start at this point, if it starts at this point, whatever it may be, so other than this point, the waveform starts at this and moves like this. So these red lines, these are the examples for time variant, because here the input is delayed by something and the output delayed version is not same as the input delayed version. So those systems, these red line systems, are nothing but the time variant systems. Okay, time variant system. If this delay is same as the delay for this one, then it is time invariant. So this is a diagram for time invariant. So for time variant, other than this, if it is not exactly at this point, other than this point, if the waveform starts at any other point, then those systems are called as time variant systems, like this, as I shown. Or if the system, it can start like this also, anywhere except this black line, except this point. If the waveform starts at any other point, that is nothing but time variant. Okay, so actually this is an example for time invariant, because see, there is a delay of tau and the output is also delayed by the same tau. But for time variant, it should be either less than tau or greater than tau. Okay, less than tau or greater than tau. Should be like this. So this red line is the example for time variant. Okay. Red line is the example for time variant. So this red line, this is for time variant. Clear? So this is the example for time variant. Now, so first I had given you the definition and I have shown you the graphical representation with the help of time invariant. Same. So it is not equal to, then it is time variant. If it is equal to, then it is time invariant. If it is not equal to, then it is time variant. So I shown you the graphical representation. Now coming to the condition. So how can we explain this mathematically with the equations? With the help of equations, how can we explain this? Now I am going to discuss about that one. Now the condition for time variant system is, y of t comma m is not equal to y of t minus m. Already I explained what is y of t comma m and y of t minus m in the previous class while I am explaining time invariant systems. The same is followed for here also. There in time invariant systems, this y of t comma m is equal to y of t minus m. Whereas for time variant systems, for today's topic time variant systems, this y of t comma m is not equal to y of t minus m. Y of t comma m is not equal to y of t minus m. So this is the only change where there is equal to. These two are equal, that is time invariant. If these two are not equal, that is time variant. Now what is this one? Y of t comma m. Already you know that y of t comma m is nothing but the output. Y is for output. Output due to the delayed input. Output due to the delayed input. That is, first I have to delay the input for some seconds. And then I have to apply that delayed input to the system. Then that system will produce some output. That output is nothing but the output due to delayed input. In general for the system we will give x of t as input. But delayed input is, if it is delayed by some m seconds. So x of n minus m or x of t minus m. Let us consider. Okay. So generally x of t is the input to the system. Now the delayed version of this one is x of t minus, if it is delayed by 5 seconds, minus 5. If it is delayed 9 seconds, minus 9. If it is delayed by m seconds, then x of t minus m. This is the delayed input. Okay. Now, if I apply this delayed input to the system, now I am applying this delayed input to the system, and it will produce the output. That output I am treating as y of t minus m. Y of t comma m, not minus. I am treating that as y of t comma m. Okay, x of t minus m. This x of t minus m is a delayed input. Now I am giving the delayed input to a system. Now the system will produce some output. That output is nothing but the output due to delayed input, which is represented as y of t comma m. So this is the first one. Now what is y of t minus m? So we all know what is y of t. Y of t is the output. If it is delayed by some time, so the delayed output is y of t minus 5 seconds, t minus 5, 9 seconds, t minus 9, m seconds, y of t minus m. So this is delayed output. So y of t minus m is the delayed output. Y of t comma m is the output due to the delayed input. So this is the two explanations of these two things. So I hope you are all clear with it. Already explained this in the previous class also. Okay, once again I'm repeating it. So now I hope you are all clear with what is y of t comma m and y of t minus m. Okay, here I will do only one thing. First, I have to apply the input signal to the system. That will produce a output. So what I have to do? First, I have to give x of t to a system. It will produce an output y of t. In second case, this x of t should be delayed. First, it should be delayed by m seconds. Let us take that value is x of t minus m, and I have to give that to the system, this x of t minus m to the system, and it will produce some output, that output I am taking as y of t comma m, that output. So the system, that is the response of the system whose input is y of x of t minus m is y of t comma m, that is output due to the delayed input. Again, here we have the output. Now what I will do, I will delay this output by the same delay in input. I will delay the output with the same delay in input. Here the input delay is m seconds, so I will delay the output by also m seconds. That is, here the delay is y of t minus m. Okay, if this y of t minus m is not equal to y of t comma m, or y of t comma m is not equal to y of t minus m, then we call that system as a time variant system. If these both are equal, that is time invariant. I already explained. Okay, so see, y of t comma m is not equal to y of t minus m, where y of t comma m is, that is a transformed version of x of t minus m. That is, this is a transformed version of this one. This is the input. So for the system, the input is x of t minus m. X of t minus m is the delayed input. So transformed version of x of t minus m is the output of the system whose input is this one. Because transformed version, we can write the y of t as, we can write this y of t is nothing but transformed version of x of t. Here we are the transformed version of this one means we are getting the output for the input x of t minus m. X of t minus m is the delayed input. So this y of t comma m is the output due to the delayed input, and y of t minus m. T minus m is directly, this is the delayed output. Okay. I hope you all are clear with this explanation. Now we will go for the problems regarding this one. Okay. Problems regarding this one. See, time variant systems. Now I will go for the problems for what I had explained now. Okay. So for my explanation, you will get clear idea if you do problems for the explanation. For that reason, I am going for the problematic explanations. So first example, consider the first example as y of t equal to x of minus 2t. They had given y of t equal to x of minus 2t. That is the problem. Now we have to prove this as a time variant system. So the condition is y of t comma m is not equal to y of t minus m. So what is y of t comma m? That is the output due to the delayed input. And what is y of t minus m? That is a delayed output. So I have to find out each one separately. If the both are not equal, then I can say this system is a time variant system. Simple. Now see, first given y of t equal to x of minus 2t. Here y of t already explained you. How can you write y of t? How will you write? So y of t is nothing but the transformed version of x of t. So for the input x of t, the output is y of t, and they had given that y of t equal to x of minus 2t. So transformed version of x of t equal to x of minus 2t. Okay. So the output is x of minus 2t. First thing. This is another form of representing y of t. First thing. Now what I will find out? I will find out the output due to delayed input. That is, what is the output due to delayed input? Y of t comma m. So y of t comma m. So that will be equal to transformed version of x of t minus m. So first here I have to go for delayed input. That is, input is delayed. Here I am considering the delay is m seconds. So you can take anything. If it is maybe k, it may be n, what it may be. Here for example I have taken m. So m may be any other variable. Okay. So if it is delayed by m, so how we have to write? Input is delayed by m second means x of t minus m. Delay is x of t minus m. So I have written as x of t minus m. And for that I need the output. So transformed version of x of t minus m. That will be equal to output y of t. When? What is the condition? That is the output y of t only when x of t equal to x of t minus m. Already said. This is the delayed input. Delayed input. So the output y of t, in that output, what have to go for? Whenever we have x of t, I have to replace that x of t with x of t minus m. I have to replace x of t with x of t minus m. See here, y of t equal to x of minus 2t. X of minus 2t. Now I have to replace this with x of t minus m. X of t minus m. That is, so this is a complete one. So what I have to write? X of minus 2t minus m. X of minus 2t minus m. Now remember this one. So here I am going for the complete function, not the variable. We are not changing t with t minus m. We are changing x of t with x of t minus m. So many will get the doubt like this while finding this value. Okay. So here the input is x of t minus m. So the function of this one is x of minus 2t. So many one substitute t minus m in place of t. You don't have to substitute t minus m in place of t, because here the variable t is multiplied by 2 and here m is a constant. M is a constant. This 2 is the scaling factor which is multiplied to the variable only, not to the constant. It is multiplying to the variable only. So for this reason, here also in t minus m, we have to multiply that minus 2 only to the variable, not to the constant. So many will substitute t minus m here, then the answer will be wrong. So what we have to do? We have to go for, here the constant is multiplied with the variable, that is scaling factor, that is scaled with respect to the variable. So here also we have to apply that scaling factor only to the variable, not to the constant m. Or simply you can remember like this also. Here we don't have to replace t, we have to replace x of t with x of t minus m. X of t with x of t minus m. So this will be more understood if you go for the more number of problems. If you do more number of problems, it will be very easy concept. Okay. So here that's why I am writing as x of minus 2 minus m. You don't have to write x of minus 2 into t minus m. So if you write like that, what happens? The t is replaced with the t minus m. Here I am not replacing t with t minus m. I am replacing x of t with x of t minus m. So first thing is one. Okay. So this is the output due to the delayed input. Now coming to the delayed output. This is very easy. Delayed output. Already I know the output. Output is this one. So that should be delayed. So delayed output is represented with y of t minus m. Y of t minus m. What is y of t? This one. So I need y of t minus m. So in place of t, I have to substitute t minus m. Wherever there is a t in y of t, I have to replace that t with t minus m. Then I get the delayed output. So simply y of t minus m equal to y of t, and wherever I have the t, replace that t with t minus m. So here y of t is x of minus 2t. So in this x of minus 2t, I am replacing t with t minus m. Replacing t with t minus m. Remember these two. So here I am replacing x of t with x of t minus m. Here I am replacing t with t minus m, because it is a direct one. So delayed output. Delayed output. Output is delayed by m seconds. So here output is y of t. It is delayed by m second, means y of t minus m. So y of t, how can I get a y of t minus m from y of t? Replacing t with t minus m. So this is the equation for y of t, and in this equation I have to replace t with t minus m. So simply x of minus 2 into t minus m. So that will be equal to x of minus 2 into t, minus 2t, minus of minus plus 2m. So this is x of minus 2t plus 2m, minus 2 into t, minus 2t, minus of minus plus, minus 2 into minus m, plus 2m, plus 2m. So simple. Now see, this is the delayed output. What is the equation of delayed output? Delayed output is x of minus 2t plus 2m. What is the output due to the delayed input? That is x of minus 2t minus m. Is both are equal? No. These both are not equal. As they are not equal, we can say that is time variant system. So therefore x of t comma m is not equal to, therefore y of t comma m is not equal to y of t minus m. Y of t comma m is not equal to y of t minus m. That is output due to the delayed input, and and delayed output are not equal. Output due to the delayed input is not equal to the delayed output. Hence the system is time variant system. Hence the system is time variant system. Simple logic. So here the confusion is only this one. You will get only at this point. So in this, don't substitute in place of t, because here the scaling factor is only the variable. Here m is not a variable. So in that one also I don't have to multiply that -2 to the constant. I have to go for the scaling factor only the variable. First thing you can remember like that, or you can remember like this. Here I am replacing x of t with x of t minus m. X of t minus m. So this one is the explanation of this first example. So I will go for another example also for your better understanding. I will explain another example and I will give 2 more examples for your work to do, for your practice to do at your home. Okay. See the next one. See the next one. Okay. Yeah. Here the example is y of t equal to x of t square. Y of t equal to x of t square. This is the example. So how can I write y of t? Y of t is the transformed version of x of t. So the first step, y of t is nothing but the transformed version of x of t, which is equal to x of t square according to the given equation, which is equal to x of t square according to the given equation. Okay. Yeah. Here see this, y of t equal to x of t square. Okay, this is the example what they had given, and we have to prove this example as time variant system. So this is a time variant system. What we have to prove? For that, we all know that the output y of t can be written as transformed version of x of t. Transformed version of x of t. So I am written y of t as the transformed version of x of t. So which is equal to x of t square according to the given equation. This is the first one. Next. So to prove that this system as a time variant system, to prove this system as a time variant system, what you have to find out? We have to find out 2 things. We have to find out 2 things. First thing is the output due to the delayed input. First we have to find out the equation for output due to the delayed input. We have to find out this one. And next what we have to find out? We have to find out delayed output. Second one is this one, delayed output. We have to find out 2 equations. One is output due to the delayed input and the second one is delayed output. If those 2 values are equal, then you can say it has a time invariant system. If those 2 values are not equal, then you can say those are time variant system. So it is an example for time variant system. We have to prove those 2 values are not equal to each other. So coming on to this one. So we will go on to that one. Now y of t comma m. Go for y of t comma m. What is this y of t comma m? I already told you. Y of t comma m is the output due to the delayed input. Output due to the delayed input. Okay. Now I am saying this one. Y of t comma m equal to transformed version of x of t minus m. So you all know that y of t is the transformed version of x of t. Y of t is the transformed version of x of t. In the same way, y of t comma m. Y of t comma m is the output due to the delayed input. Output due to the delayed input. Now here the delayed input is x of t minus m. So I can write this y of t comma m as transformed version of x of t minus m. Transformed version of x of t minus m. Okay. That will be equal to output y of t and x of t equal to x of t minus m. X of t equal to x of t minus m. Because for the system the input is delayed input, that is x of t minus m. For the system the input is x of t minus m, delayed input. Okay, delayed input. That will be equal to y of t at x of t equal to t minus m. Substitute. What is y of t? This one, x of t square. Now what I have to substitute? I have to substitute in place of x of t minus m. Here it is x of t square. So what I have to write? X of t square minus m. X of t square minus m. I am once again repeating, don't insert t minus m in place of t. If we insert t minus m, because its t square is only for the variable, t, only for the variable t, not for the constant, So for that reason, here also we have to go for this t square only for the variable, not for this m. Or simply we have to replace this x of t. We have to replace this x of t with x of t minus m. So x of t square minus m simply. So first thing, here we are not replacing t with t minus m. We are in y of t, we are replacing x of t with x of t minus m. So the equation is x of t square minus m. Okay. Now the delayed output is, so this is the output due to the delayed input is x of t square minus m. Now I need a delayed output. What is the delayed output? It is a very simple one. So delayed output is simple one. So output is y of t. It is delayed by m seconds. So I have to write y of t minus m. Wherever there is a t, we have to replace that t with t minus m. So y of t minus m equal to, in this equation I have to replace t with t minus m. So y of t at t equal to t minus m. So that will be equal to x of t minus m whole square. X of t minus m whole square. See, this is x of t square minus m. This is x of t minus m whole square. These both are not equal. That is, output due to the delayed input is not equal to the delayed output. That is, output due to the delayed input is not equal to the delayed output. Y of t comma m is not equal to the y of t minus m. Hence, the system is time variant system. Okay. So, in this way, you can go for any number of problems. I hope you are all clear with this one. Only two things. You have to find out output due to the delayed input and delayed output. Delayed output is same, because in the equation of y of t, I will replace t with t minus the delayed input, t minus m. Here the delayed one is m, so I will replace t with t minus m. But we have to find out output due to the delayed input. That is, first of all, I have to delay the input. And then I have to apply the delayed input to the system. And I have to find out the output. There, in the output, I have to replace x of t with x of t minus m. Replace x of t with x of t minus m. So there is the only difference. Here I have to replace x of t with x of t minus m in y of t for output due to the delayed input. And for delayed output, we have to replace t with t minus m in the output y of t. Okay, so these are the two examples what I explained, and I will give two more examples for your practice. Okay. See, time variant system. Already I have given time variant system. So y of t equal to t square into x of t, and y of n equal to x of n by 2. So this is the continuous time variable, and this is a discrete time. This is for continuous time, and this is for discrete time. So I will explain the discrete time now itself. Okay, not the problem. I will explain the theory about that one. Based on the theory, we will do this problem. You can do the problem. Okay. So the concept for continuous and discrete both are same. Here, for continuous I will use t. For discrete I will use n. That is the only different. For continuous I have taken m seconds. For discrete you can take k units. That is, replace m seconds with k units. So t is replaced with small n. In the same way, m will be replaced with small k. So those are our wish. You can use any variable there. Okay. So these two are for your practice. So you will do this at your home. Now, next, simple time invariant and time variant system of discrete. So discrete, time invariant and time variant. Up to now I explained you the continuous. So for discrete also, I already told you that only the difference is, in place of t we have to substitute n. T for continuous time and n for discrete time. See, for continuous this is x of t and this is y of t. For discrete, this is x of n and that is y of n. Simple logic. Now, there x of t is delayed by m seconds. Here x of n is delayed by k units. Then what have to write? X of n minus k. And output is y of n. And output is delayed by there y of t is delayed by m seconds. Here the y of n is delayed by k units. So I have to write y of n minus k. Same. There t is replaced with n here. There m is replaced with k here. That's only t with n and m with k. That is only difference. Everything, explanation, everything is same. See, if this is a delayed output and this is delayed input. Now I am giving the delayed input to a system and it is producing some output. So the output due to the delayed input, this is a system. The system is producing a output. For the input, delayed input. Okay. The output due to the output. See, the output of the system for the delayed input is same as the delayed output. Then we can call that as a time invariant system, or we can call it as a shift invariant. Generally for discrete we will use shift in place of time. That is shift invariant system. So this is an example for shift invariant. What about shift variant or time variant? Time variant. Simple. If the output of the system, the output for which the input is the delayed, output due to the delayed input is not equal to delayed output. If output due to delayed input, for the system the input is delayed input, the output due to delayed input is not equal to the delayed output, then that system is called as time variant system or shift variant system. That system is called as time variant system or shift variant system. That is, output due to the delayed input is not equal to the delayed output. Simple. Here system input is x of n, output is y of n. System input is x of n minus n. That is, delayed input is given as input to the system. If that output is not equal to delayed output, then it is time variant system. If the output due to the delayed input is same as the delayed output, then it is time invariant system. So I can explain this graphically also. How can I explain this graphically? See. So this is the graphical representation example. Simple. What I explained before, the same thing I explaining graphically. See, this is the input x of n. For this, I am getting the output as this one. So see, here the values are like this: 1, 2. So this is 2, 1, 2, 1. So x of 0 equal to 3, x of 1 equal to 2, x of 0 equal to 3, x of 1 equal to 2, x of 2 equal to 1, like this. For this output, y of 0 equal to 1, y of 2 equal to 3, y of 1 equal to 3, y of 2 equal to 4, so on. So for this input, this is the output. If I give this input to a system, it will produce output like this. Now, it is delayed by n0. Here the example I have taken as n0 units. If it is delayed by n0 samples, that is shifted n0 samples front side, delayed. So it is delayed by n0 samples and is given to the system. System is producing the same output with the same delay what there occurred in the input. So input there is a delay of n0 units. So in the output also if there is a delay of n0, same delay is occurred. That is, the output of the delayed input is same as the delayed output. Then this is an example for time invariant or shift invariant system. This is an example for shift invariant system. Simple logic. The input is delayed by n0 samples. Okay. The output is also same as the delayed output of n0 samples. Here this is the output. The output is delayed by n0 samples. If for the system the input is delayed by n0 samples and what we get, if we get the output by delay of n0 samples, then that system is called as time invariant system. Okay. Now if I want to go for the time variant system, that is, for the input x1 of n, the output is y1 of n, same thing. Now see this one. The input is delayed by n0 samples. Input is delayed by n0 sample and that is given to the system. If that output is not equal to this one, if that output is not equal to this one. That is not, output is not equal to delayed output. Other than this one, if you get anything, that is a time variant system. That is, the sample start at this one. The sample start at this one. The sample start at this one. Okay, this red lines, see the red lines. That is, the sample is starting at this, not n naught samples. So it is shifted by n naught minus 1 samples. N naught minus 1 samples. That is, here n naught samples, here it is n naught minus 1 samples. That is, the graph is not as same n naught samples mode. So for input, there is a delay is n naught samples. In the output, the delay is not n naught samples. That is, there is a variation in input and output characteristics. The input and output characteristics vary with time. Then those are nothing but, we call it as time variant system. Simple. For this, input is x1 of n and output is y1 of n. So input is delayed by n naught samples and that is given to the system. If the system produces an output which is not equal to the delayed output, not equal to the delayed output means the output is not like this, other than this, anything other than this, that is, if it is shifted backside or shifted front side. Okay, if you start the samples from here, or you can start the samples from here, or you can start the samples from here. The shape is same. The starting point of the samples is here or here or here or anywhere, not at this point. Because if it is at this point, it is equal to delayed. Not equal to means either n naught minus 1, n naught plus 1, n naught minus 2, n naught plus 2. So if it is started, the samples are started at this point or at this point or at this point, then what happens? The output due to the delayed input will be not equal to when the sample starts at this point, or if the sample starts at this point. So then it is not equal to, that is, the output is not equal to the output due to the delayed input is not equal to the delayed output. Then the systems are called as shift invariant systems. The systems are called as shift variant systems or time variant systems. Sorry for that one. So only one thing, if output, this one, see, output due to the delayed input, here the input is delayed by n naught samples, and that is same as the output which is delayed by n naught samples, then it is nothing but time invariant. Now the second one is if output for the input which is delayed by n naught samples is not equal to the delayed output, that is, the graph is not like this, other than this one. That is, see, sample started to here, next to here, next to here, next one, next one. So red mark, this is our graph. Consider this is our graph. So here the delay is not n naught. Then this is an example for time variant system or shift variant system. I hope you will get a clear idea of graphical also. Simple. Not equal to this one. This is already no. Not equal to this one. That means samples start at this point, this point, this point. Other than this, you can start the samples at any point. The shape is same, but the sample starting point is different. Then those systems are called as time variant systems. Okay. And I will finish with this one slide. Yeah.
40 minutes in that.
The last one, a linear time invariant system and a linear time variant. LTI and LTV systems. Now, simple ones. Up to now, I explained you about time variant system. In the previous classes, I explained you about linear system, non-linear system, time invariant system. Okay, linear system, non-linear system, time invariant system. I explained you previously in the previous classes, and today I explained you about time variant. Now, the combination of all these four will give two types of systems. One is linear time invariant system. Another one is linear time variant system. Simple. LTI, linear time invariant. LTV, linear time variant. LTV, linear time variant. LTI, linear time invariant. Simple. If a system is both linear and time invariant, that is, if the system satisfies the properties of both linearity and time invariant, then the system is called as linear time invariant system. Linear time invariant system or simply LTA system. If a system is both linear and time variant, then that system is called as linear time variant system, LTV system. Simple logic. System satisfies linearity and time invariant, then it is called as linear time invariant system, LTA system. This system satisfies linearity and time variant properties, then that system is called as linear time variant systems. So if it satisfies linearity and time invariant, then it is called as LTI, linear time invariant system. If a system satisfies linearity and time variant, then that system is called as linear time variant, that is LTV, linear time variant. Here it is linear time invariant. So this is about linear time invariant system and linear time variant system. So I will go for the summary of today's class, what I explained. So in this class, what I explained, we'll go on. So summary. So I am going for the summary here. Okay. So summary. The summary of this class is, first thing the summary is, first I explained you what is time variant system. What is time variant system? And I show the graphical representations using time invariant. And then after that I gone for some problems. I had given the condition, equations. I had given the condition for time variant, that is the equation. I have given the equations. So if that equation is satisfied, then it is called as time variant. Based on that equations, based on that condition, I had done some problems. I had done 2 problems with respect to time variant systems, and I had given 2 more problems for your work, for your exercise at your home. And after that I gone for the time invariant and time variant system with respect to discrete. So discrete time variant and time invariant systems I explained, and lastly I explained you about linear time invariant system and linear time variant system. So this is today's class. This is the summary of today's class. Thank you one and all.